questions live one-to-one with me. So let's get started our class for today. Before we start, a quick housekeeping stuff. I'm sure you will have all got the request for our training blog. This is one-stop shop for all the material of this training. In the first tab, you can see the session recording of each class will be published. As we are starting the session from the beginning, our class number 2 is planned today, which we are doing. After the class is done, next day before 12 o'clock, you will get the recordings of this today's session. And the process goes on and on. As in when we continue our classes, these recordings will be updated regularly afterwards. The second tab here is the class schedule tab where you can see all the links of our meetings. Right now there is some problem. I need to look into it perhaps. So this is where you will see the links for our classes, our regular classes. Yes. So right now there's some problem. I might need to fix it. I need some time. Maybe during the break I will fix it today. The third section will be the study material tab. This is where you will be finding all the study material for our training, including the PPT which I'm writing here will be available right after the class in this study material tab. Our batch dates are also going to be updated. So this is work under progress. We will update the 3 tabs during the break time and I will also take you through that. So having said that, let us get started. It is our first day and our topic for today will be getting started with SAP HANA introduction. If you're facing any administration related issues like block access link and all, please feel free to drop an email on contact@anubhavtrainings.com. For time being, I have also shared the blog link with all of you now in the chat window. You can bookmark the same accordingly. Having said that, let's start our session for today. I would also request to kindly put your doubts, if you get any, into the chat window. So once I give a logical close to the topic, I can take up those doubts accordingly. So what is SAP HANA and why ABAP on HANA and how SAP HANA came into the picture? So let's understand what is SAP HANA and its main power and how come ABAP on HANA or SAP HANA is becoming so popular into the market. So first topic we will start is what is HANA. HANA stands for High Performance Analytic Appliance. It is SAP's in-memory database. Since it is a database, why it is called appliance? Because HANA is not just only a database. It is a combination of hardware and software. And this is why it is called appliance, which means this is not like Oracle database which you can run on your personal computer. HANA, in order to run HANA database, we required specialized hardware. And this specialized hardware has to be purchased only from SAP certified vendors, which are right now 3 in the market: Dell, Lenovo, and HP. Only the hardware which is provided by these certified vendors, we can use it to run HANA on. Unlike Oracle database, we cannot run HANA on our personal computer for productive uses. This is why HANA is called appliance. How this database is different from traditional RDBMS system which we learned during college days. I'm sure all of you, those who come from software background, have learned about computers and databases in college days. So typically we all know the computer includes a CPU where all the processing of the data happens. The CPU itself has CPU registers, or so called CPU caches, C1, C2, and so on. So these are called internal registers of CPU where the data is kept for the CPU to process. Then we have the RAM, or primary memory, which is also known as flash memory, which is little costly and it is getting connected to CPU. There was a subject in my college called microprocessor and micro controllers in college days. There was a concept of 8084 IC which was taught to you in the college days, if you remember. So the amount of memory which you can attach to a CPU is 2 raised to power n, where n represents the size of address bus. I hope you remember 8084 IC of college days. Yes, those who have recently passed out, you will certainly remember. I completed my engineering way back in 1995, and I still remember the 8084 IC and its diagram, circuit diagram. So this is a size of memory which you can attach to the RAM. Then we have something called a secondary memory. It's called as hard disk drive. All the computers or traditional databases, they will keep all the data in the hard disk. There are two reasons. One is the limitation of the size of address bus which this CPU can point to. And second reason is the cost. The cost of RAM is comparatively higher than hard disk. But this way of storing data using traditional RDBMS system is a big problematic thing because it creates a performance bottleneck and it takes a lot of time to process this data from hard disk to RAM and the RAM to CPU. This is how traditional DBMS system like MaxDB, IBM DB2, DB6, MySQL, SQL Server, or Oracle database works. SAP revolutionized this concept and they said bye bye to hard disk. We can keep all the data in the RAM. This will certainly give a boost to the performance of your processing of data. And this is the main difference between HANA and traditional RDBMS system. But it can only be done on a specialized hardware, which means you really need a humongous size of RAM to handle this. Yes. So this is how we can achieve data store it directly into RAM. But there are multiple questions might hit your mind. What about power goes off? Yes. Won't the system be too costly? So guys, answer is hidden inside the recent decade software and hardware innovations in the market. So let's talk about some of the hardware innovations which happened in the market which made SAP HANA-like database possible. So there is a drastic reduction in the memory prices over a period of time. I remember way back in 2002, I was traveling to Delhi, and in Delhi there is a place called Nehru Place. That's where you can find latest and greatest gadgets in the market. I purchased my first iPod when people didn't even heard about iPod. I bought it in 2002 and I paid whopping $600 for that. Today, and that iPod which I bought was hardly storing 500 megabytes of songs. I could hardly store 20, 30, 40 songs of my choice into that iPod. Yet I was very happy to see that. Today, at the same cost of $600, you can buy a whopping memory of more than multiple petabytes, which can actually store all the songs which you and your family would like, right? So you all have experienced this. There is a drastic reduction in the memory prices over a period of time. And this is what major factor is to is for the companies like SAP to come up with a concept and a design where it is possible to bring now and keep all the data into the RAM itself. And it is also affordable for companies to use such a system. Then the second innovation which happened in hardware industry was multi-core CPUs. I'm sure you have all heard about when you buy a new smartphone next time, you will hear this term called octa-core powerful processor. Octa-core, dual-core, quad-core. Quad-core means there are four cores inside a CPU. Octa-core means a CPU which is consist of 8 cores. So if you talk about a octa-core processor or a quad-core processor, there are 4 blades. On a single blade, you have 4 CPUs. Yes, each core act itself like a CPU. So you technically have one blade. It has 4 CPUs embedded inside. And using this kind of device, it is possible to actually run a very powerful system, and each core of the CPU can actually run the processing in parallel mode. So one core can process one data, another core can process another data, another core can process another data, and another core can process another data. And if you connect this kind of CPUs, multiple CPUs together, it is also possible. So technically you can achieve a very massive scale of system where the processing power of overall system is going to be humongous. So if I connect like 12 pieces of quad core processor, we will get a computation power of 12 into 4, and that is called one node. Likewise, if you connect 64 nodes together, you can actually attach petabytes of memory to such a system. And such a system can cost less than $50,000, which is nothing for a company. Companies like Nestle, companies like Walmart, BMW, it is nothing. These are pennies. They can really afford now a system which can really do a massive parallel processing of data, keeping all the data in the RAM. Such an affordable system can be designed. The third innovation which happened in the industry of hardware was also ability to make memory portable. I'm sure you are a big fan also, like me, James Bond movies. James Bond carries a very small pen which contains a chip to store and steal the enemy data, right? So today it is possible to fabricate or design memories which are very portable at a size of nail, and you can carry them and manage them very easily. This has also made the overall system look smaller and compatible to store humongous data. You don't need big size racks to store huge data. The memories are becoming more portable. Ability to fabricate more powerful CPUs where data can be processed in the upper caches of CPU. So SAP worked in close with the certified hardware vendors to also come up with special fabrication techniques to design CPUs in a way that HANA can leverage the full potential of CPU by processing more and more data in the C1 cache of CPU. As I told you, a CPU also has caches where it uses the data and process it. C1 cache is where the data processing throughput time is in gigabyte per second, yeah, or petabyte per second. C2 cache again less gigabyte, then less gigabyte and less gigabyte. So SAP have come up with a concept in collaboration with companies, hardware vendors to also process data in the upper caches of CPU, which are also going to give great computational power. This is another innovation in the industry of hardware, which is making it possible. The next innovation is ability to have 64-bit operating system. What is 64-bit operating system? Coming to college days, I'm sure some of you have studied this microprocessor subject in college days. We used to have a microprocessor lab where we used to write move A, comma B, this kind of a machine instruction, right, to a microprocessor. So we are moving data from register A to register B. So this is called a instruction. So how fast the microprocessor can interpret these instructions and how fast you can feed these instructions, it is what done by operating system. So you can see a 64-bit operating system can feed billions of extra expressions like this to the hardware in no time, in the blink of an eye, as compared to 16-bit or 32-bit operating system which we used to use in the past. Most of the OS these days are 64-bit operating systems, which has a high throughput time to give instructions to the hardware to let the hardware used its maximum capacity to gain the good performance. So these are some of the great innovations which happen in industry, which is changing the world forever, which is what changing or allowing companies like SAP to design, rethink and redesign ERP systems and databases in a way which runs much faster. Coming to the software innovation, as I told you, HANA is an appliance. An appliance is a combination of hardware and software. So there are also software innovations which SAP come up with, which is what made SAP HANA possible. So the first software innovation is called row store versus column store. So there are two ways to store data into database table internally within the database. Row store is the way where data is stored for each column in a consecutive memory location where rows are stored together. Whereas in a column store, all the column data is stored together. If you're confused about this, I will show you this more into the next slide itself. So our next session, next slide, I will talk about dedicatedly on this to explain you the concept of row versus column store. This has also improved great benefits or given great benefits when it comes to working with SAP system like HANA. Then ability to compress data. There are compression algorithms which are available nowadays, which brings down your data size to very low size. So gigabytes of data can be compressed into megabytes of data. This way you don't need to have a large size of memory to store the same data. So good compression algorithms in the software industry made it possible to concise your data and store it is still into the RAM. The next innovation which happened is ability to or deletion of aggregate tables. I will explain this maybe in my next slide, making you understand the deletion of aggregate table or what we call it as on-fly aggregation. We will talk about it in our next slide in a minute. You will understand it much better. Then we can get rid of secondary indexes in database, which will further bring down the footprint of the data store. The next innovation is also getting rid of or getting away from using the insert only approach. I will also explain this in the next slide for better data tracking and avoiding the store of duplicate data into the system. So these are some of the software innovation which helped SAP to design or come up with database in HANA. Remember one thing, as a developer perspective, when you work with database, you still use data dictionary in SAP. You still use SE11, you still create data element, you still create domains. Those things haven't changed. What am I showing you today is internal kitchen of database. How HANA database is cooking the data, how it is using the data, how it is organizing the data inside. The next main advantage is data partitioning. Data partitioning is a technique where you store the relevant data together. Just think of an example of your cupboard. I was a naughty boy in school day. When I used to come from the school, I used to throw my tie, my belt, my shoes, my trousers, my t-shirts here and there in the room. Yes. When I grown up, I realized that the things which you throw away, you would need them in the next day. As you grow, you start using cupboards. You start organizing your stuff into cupboards by putting all the ties together, all the socks together, all the trousers and jeans together, all the coats and all the top wears together, right? So that next day when you are getting ready for school or college, you can find the stuff pretty easily. Exactly same thing happens in a database. Database is a big cupboard. Database stores all the data inside itself, and if it is done in a very organized way, it is easy for database to fetch this data faster. For example, organizing master data together, organizing transaction data together makes it possible for database to quickly go and find out the correct compartment where the data is. This is another benefit of HANA, where data partitioning internally helps HANA to organize and fetch data faster. So to deep dive inside these software innovations, let me explain you how SAP HANA works internally. Once again, I would like to repeat here, I would like to repeat here, I would like to repeat here, I would like to repeat here that it does not matter for you as a developer to work with these things, how database is working internally. This is all the internal functionality of database or HANA. As a developer, you still use SE11, you still do things the way you've been doing in the past. It will not change. For you, still you create data element, still you create domain, still you create tables using SE11, still you define columns, still you manage data, still you define data category and everything. Remember, these are internal kitchen of database. This is internal behavior of HANA database. It will not directly affect you, but it will help you to understand what made SAP HANA possible for company like SAP. Having said that, let's start with software innovations. So the first is called row versus column store. Let's understand what is row versus column store. So let's take a simple example of real-time data. I will assume that my company have lots of sales data in the system. We have sales orders. So I have data of sales orders, which is being stored in my company system, for example. And when it comes to traditional databases like Oracle, we use row store. Row store means all the data of a row is stored together. Let's take an example of a couple of sales order in my company. So I have the sales order, I have order details including order amount, material, and customer information. So let's say order number one, customer is one, material one was sold with the 200 US dollars. Order number two, where it was sold for customer two, material two was sold at 900 US dollars. Then order number three, I have customer one again with material two was sold at 500 US dollars. And order number four, I have customer two, which is buying material one at 550 or 600 US dollars. You can notice I have total four records, and all the four records is stored in a row fashion, which means all the data here is stored in a row way or a row fashion where data is kept in the row format. All the data is stored consecutive memory location in the database in the memory. Now, let me ask a question to the database. Guys, please be interactive in the class. More you interact, more you give answers to me in the chat window, it will motivate me to give you more. If you want me to give you more in this training, more than what you expect, believe me, you got to contribute, you got to react, you got to respond. I will not go to your manager and I will not complain your manager that you gave a wrong answer, but try to give an attempt, try to be interactive, try to give an answer for the questions which I ask you in the chat window. It will motivate me, it will give me more energy, and I will be able to give you more than what is planned for this training. I will see the response of your batch, and based on your response, it will motivate me, it will give me more energy. But if you guys not respond, if you just come like a bad listener to the class, then it will decrease my motivation, and I will just come give lecture and go away. I will not get it from my heart to give you more energy, to give you more content. So if you guys really want me to motivate, if you really want me to give you more and more in this training, you guys have to contribute. It doesn't matter whether you give me right answer or wrong answer, but it will help me that you guys are listening. It will help me to understand how depth are you able to understand or not. Okay, so now my question is, how many cells I need to traverse or database need to traverse to get total sales? Anyone? In this database table, in this organization of data, how many cells, what do you feel, how many cells I need to traverse or database needs to traverse in order to get the data? Can anyone think? All the cells. Very good answer. Thank you so much. All the cells actually. Why? Because database has to start a scan left to right, top to bottom to fetch all the cells. So it will go like this. It will start a scanning like this. Exactly. And wherever it finds the amount, it will take only the amount eventually to show the data. So what database will actually extract is this value, but in just order to even extract this particular value, our database has to traverse all the cells. Though we are just extracting the total amount for the sales orders, we even have to traverse all the cells. Yeah. So this is bad. This is a bad way of organizing the data, that I have to traverse all the cells in the memory